Hello guys and welcome to this video, and in this video I'm going to show you how you can make a first person player movement in Unity. And if you are looking for how to make a video game, we have a series on it. The link will be provided in the description. And so without further ado, let's get started. This is an empty scene with a ground object called cube. So to make our first person player in Unity, go into hierarchy, right click, create an empty object and just rename it as our FPP, means first person player. And in FPP add a component called character controller, and when we create a character controller we can see a grid outline created in here. And if it isn't visible in your Unity, you must enable first this gizmos option here, and if it is enabled you can definitely see it here, but it is not visible in our, we can see that our game panel. So to make it visible, go into our FPP, right click and create a 3D object called cylinder. And when we create a cylinder, we can see our, what we say, we can actually see our player, and just make it stand on the ground. And now drag our camera into our FPP and reset its transform so that it snap in middle of our first person player. And now to look like a first person view, we need to first reference our player body, means when we rotate our main camera on horizontally like this, we want to rotate our whole player body. But when we rotate like this on y-x, on vertically, we don't want to rotate our player body. So to do this through script, select our main camera and add a new component called a new script which will be called like player cam, and create an ad and open it up in Visual Studios. Now to move our player body on horizontally like this, we need to reference our player body here. So to take the reference, we need to write public transform and simply player body. And if we save this and go back into Unity, and now we can reference our player body into our player cam script. And in our update method, we have to make a new float called mouse x, which will be equals to input dot get axis mouse x. And this is a callback function made by Unity itself. And if you want to see it, go back in Unity under our edit project setting. In our input manager you can see a mouse x and a mouse y. So in again our script, let's find a way to control our mouse sensitivity. So to do that, to control our mouse sensitivity, now make another public float called mouse sensitivity, and in short form just mouse sensi, which will be equals to our 100f, and multiply with our input.get axis mouse x, multiply this with mouse sensi, and to make a frame rate independent, multiply with time dot delta time. And like this we have to do with our mouse y also. So make another float called mouse y, which will be equals to input dot get axis our mouse y. Now multiply with our mouse sensi and our time dot delta time to make frame rate independent. And now we have to rotate our player body with our mouse x, as I have shown you before. Like when we rotate our camera like this, we have to rotate our player body also. So To do this, in our update method, write player body dot rotate and open and close brackets. In open and close brackets, write vector 3 dot up into our mouse X. And now when we save this and go back into Unity, we can actually see it working. And indeed it works. So to make things more looking like first person view, we need to rotate on Y axis also. So to do this, let's make another public float called X rotation, which will be equals to 0f by default. And under our update method, we need to write X rotation minus equals our mouse Y. And why we are putting here minus? Because if we put a plus here instead of minus, the rotation of our camera movement will be flipped. Means the rotation when we move our mouse down, the rotation will be of upward, and when we move our mouse forward, the rotation will be downward. Now to make this really working, we need to write transform dot local rotation, which will be equals to quaternion dot Euler, and in which X rotation, comma 0f and comma 0f, and just close with semicolon. And when we save this and go back into Unity, and play, we can actually move like, we can actually not move, we can actually see like a first person view. But there is a problem. Means when we rotate on like this, everything is fine, but when we rotate our camera on vertically like this, we can rotate a 180 and a 360 and so on, and we don't want this to happen. So we can use a clamp. This is a math f function provided by Unity. So to do this, under X rotation minus equals mouse Y, we have to write X rotation equals to math f dot clamp, and we have to clamp our X rotation on minus 90 degree and 90 degrees. So now when we save this and go back to Unity, this will probably work. And it is like, when we look down, we cannot look behind our 90 degrees, and up it's same. So when we have done with our camera movement in first person, we can now proceed to make a player movement in first person. So if you like this, now make a player movement in real, means in our make our first person movement in Unity. Let's select our cylinder, add a component, and the component will be a new script, and the script name is player movement. And create a new script and create an add and open it up in Visual Studios. And first thing that the first thing that Unity has done a lot of work by giving us a character controller, which will take the record of slope limit, step offset, skin width, minimum move distance, and so on. So the best thing we need to do is taking a reference of our character controller. So to do this, write public character controller and just name it controller. And when we save this and go back in Unity, we can actually reference our character controller. Select our cylinder, drag our FPP on it, and you can see that FPP, and in open and close brackets we can see character controller. Now when we have our say reference of our character controller, we can now proceed to make things happen, means make our first person movement in Unity. So to do this, go back into our Unity, Unity nahi apni, means our script, and in our update method make a float called move on x, move x, which will be equals to input dot get axis, and in open and close brackets we have to write horizontal. And you are thinking right that it is also a callback function made by Unity. If you want to see it again in project setting, you can see horizontal and vertical. And now in our script we have to, and also we want to move our player on X and on Z, but not on our what we say on, we don't want it to move on X axis like this. So in our script we have to write float move Z, which will be equals to our input dot get axis and vertical. And down here we have to write move is equals to, not move x, only move, and not only move, a vector 3 move, which will be equals to say transform dot right into our our move x, and plus transform dot forward into our say move z. And down here we have to write controller dot move, capital M move, and open and close brackets, in which we have to write move into our speed. So just make a new public float speed, which will be equals to say 10f, and down here we have to write move into our speed, and to make frame rate independent we have to multiply with time dot delta time. And now when we save this and go back into Unity and play, we can now move our player in first person movement. But there is a problem, like when we take our say FPP and drag it up, the gravity is not applied, we are floating in the air, and that's nobody wants this. So to make it happen, means to make gravity, go into our player movement script, and here write and another say public float called gravity, which will be equals to our Earth's gravity, which is minus 9.81. And now under our controller dot move we have to write, but first let's make a vector 3 called velocity, and down here we can write velocity dot y, means when we apply our gravity is will be equals to our gravity. And down here we can write controller dot move open and close brackets gravity, not gravity, velocity into our time dot delta time. And also when we set our velocity dot y equals to gravity, we have to multiply with our also with time dot delta time. And yes, now when we save when we set our velocity dot y equals to our gravity, we have to write a plus, means velocity dot y plus equals to our gravity. I forgot to add there, means add a plus there. And now when we play this, hopefully everything should be fine, and indeed it is. So the thing that the error I'm telling you about is that when we hit play, you can see that gravity is working just fine, but when we stand on the ground for a little while and then try to say go off the ground, we can see that how quickly it goes, because when we actually standing on the ground, means when we really standing on the ground, we can see in here, if we go into debug mode and see that our velocity on y is just increasing and increasing and increasing. So to make this stop, means make it stop, like to tell this we are standing on the ground, we need to go back into Unity, means our script, and make a public layer mask called ground mask. And also we need to write public transform and call this ground check, and also a public float called ground distance, which will be equals to 0.4f, and a bool is a boolean system, means a true or false statement. So a bool is grounded, means we are actually standing on a ground. So in our update method, we have to write is grounded is equals to vector3 dot vector3 dot not vector3, we have to write physics dot check sphere, and in this we have to write ground distance dot position, no, we have to write ground check dot position comma ground distance comma ground mask. And when this is done, we have to write another statement called if is grounded and velocity dot y is less than 0, means we are actually standing on the ground, then we want our velocity dot y is equals to minus 2f. And when we save this and go back into Unity, and we can see that there is a ground mask, a ground check, and a ground distance. So let's quickly go into our FPP and right click and create an empty object called ground check, and I have to focus it and just place it at the bottom of our player. And in our script, we can drag our ground check into our ground check slot, and in our ground mask we have to go into our layer and add a layer and add a ground as a new layer. So when we select our cylinder, we can add our ground. And also we need to just know this is it, but we have to take our ground and change its layer to the ground layer. Means we have to change the layer to the ground layer. And now when we play this and go into debug mode, we can see that our velocity on y is increasing, and the method we write is worked. And you can also see that when we go, you can, yes, it is not happening like before. And also we can make our player jump. So to do that, we need to write if is grounded is true, and then we need to write here, and if we get input dot get button down, and the button is jump, and it is also a callback method made by Unity. And if input dot get button down jump and is grounded, then we need to make our player jump. To do this, we need to write velocity dot y is equals to maybe a 2f. And when we save this and go back into Unity and hit play, we can see that we are jumping, but it is not so what we say high enough. So make it a 6f, and when we play, this indeed will work. And yes, oh, where is it gone? So you can see that we can jump now right now and move our player like this. So yeah guys, if you like this video, make sure to subscribe so you won't miss another update of this channel. So till then, bye.